So today we'll discuss about kinetics of microbial growth. So unicellular organisms, they divide by binary fission. So one cell divides into two, two into four cells, 4 to 8, and similarly that means 2 raised to power n. So unicellular growth usually occurs in a series of different phases. Okay, so first growth of unicellular organism, it consists of different phases. First we'll take lag phase. Now what happens in lag phase? If I take when an inoculum of bacteria will introduce into some growth medium, right? So first we will grow bacteria. So we'll place that bacteria into some growth medium. So it will probably require a period to adapt to its new surroundings, right? So it will take some time to grow. So that is basically the period of adaptation. So bacteria, it requires carbon source. So definitely the cells will take their time to grow, to synthesize necessary enzymes for their metabolism, right? So the length of lag phase will depend on age and general health of the cells in the inoculum. So during lag phase there is no net increase in bacterial numbers, right? So the cells are basically metabolically active, but there is no growth, no net increase in bacterial cell number. Here it is just taking its time to adapt to new environmental conditions. Okay, next, then second we have log phase. So log phase, that is also called exponential phase. So when bacteria have acclimatized to their new environment and synthesize the enzymes, they require available substrates. So now here cell division starts. So now they divide by binary fission. So now what happens, as the cell divides, it leads to exponential increase in number. Cell number will grow, that means exponential growth is there. So exponential increase in number will be there. So under optimal conditions, the population of cells will double in a constant and predictable length of time. So here next we have general population doubling time, that means 2 raised to power n. So now basically the time for E. coli, that is 20 minutes, and for most organisms it's less than an hour, but here we have to consider E. coli. So there are some bacteria whose generation time is in many hours. So number of cells, they are expressed as Nt is equal to n naught into 2 raised to power n. So here Nt means number of, sorry, one sec. So here Nt means number of cells after time t, and then n naught. N naught is number of cells at the start of exponential growth. And then 2n, that is the doubling time. Okay, and next we have in lag phase only diauxic growth. 1 minute. Diauxic growth. This comes under log phase only. So now what happens in diauxic growth? Now E. coli, if we take E. coli and grow it in a medium, and medium it contains glucose and lactose. So obviously, so now here what he will choose, will bacteria choose glucose or lactose? A cell has a regulatory mechanism that suppresses the synthesis of lactose metabolizing enzymes until all the glucose has been used up. So so bacteria will prefer glucose. For example, like we humans, we choose our preference, like what we like, right? Pizza or chapati. If I prefer pizza over chapati, so pizza is my first preference. Similarly, bacteria's first choice is glucose. Glucose, that's the eating material for bacteria. So he will first choose glucose. If glucose has finished, then he'll come to lactose. Second option is lactose. Okay. So at this point, a second lag phase is entered when lactose metabolizing enzymes are synthesized. So first he will use glucose, and when glucose is finished, it's all utilized, he has no other option, then we will come to lactose. So this is basically termed diauxic growth. So the graph is like this. Here we have bacterial growth rate. Here we have time. Okay, then so this is growth on glucose. This line denotes glucose is being used up. He has eaten glucose. Then this line depicts growth on lactose. This is for lactose. So basically two ingredients are there, glucose and lactose, right? So that's it. That's why it's termed diauxic growth. Okay, so next we have, okay, so so coming to that equation, NT is equal to N naught into 2 raised to power N, and NT was total number of cells, and N naught number of cells at the start, that is initial, okay, and number of cells after time t, not total. Then L is the length of the lag phase. Okay, after that, so there no numerical based question will be there, only this lag log phase are important. So if we know the number of cells at the start, so we can determine the graph. Okay, after that we have stationary phase. Now what happens in stationary phase? Now after this exponential phase, now the rate of growth slows down. Rate of growth slows down. So the culture here enters the next phase. Now leveling out of growth curve does not mean that cell division has stopped completely. Stationary basically means now no more cell division can take place, but here what happens, there is increase due to newly formed cells. The new increase due to newly formed cells is cancelled out by a similar number of cell deaths. Now what happens is death rate increases. So death rate will increase, then overall cell number will fall, right? So basically in this phase cell division stops and cell dies. Okay, coming to now after stationary phase, here we have death phase. Now stationary phase, what happens is stationary phase is like no more cell division can take place. For example, saturation. If I take a glass of water and if I keep adding sugar to it, if I keep adding 10 spoons, the handful of spoons to the water, right, a point will come that no more sugar can dissolve. Similarly, in stationary phase, a point comes, no more cell division takes place. So that's the saturation point, that's the full point, right? So coming to death phase, so here cells die off as the name depicts. Cells die off and the culture is unable to replace them. So the total population of viable cells, viable means living cells, they falls. No more living cells are there. So this is the death, or also called decline phase. Okay, now let's see graph of this. Okay, that was for Diauxic growth. Okay, so here this is cell number, here we have time, right? Okay, then this will slightly, it will go up, this stationary phase. Now decline, that is death phase. Now this part, this was the initializing part, so this is the lag phase. Now as the number of cells grow, this comes to log phase, 2n, here it will come 2n. Now no more cell division takes place, that comes under stationary phase. Now when cells die, they come under death phase. Okay, so this was about microbial growth curve. So first let's start the revision. Lag phase. In lag phase it was about starting, it was about initializing. So in bacteria was just introduced, it will start adapting to new environments. Now log phase, it will start to divide, when one cell will divide into 2, 2 to 4, 4 to 8. So similarly it will formula will come 2n. Now why I have written 2n? Because if I say 2 raised to power 2, it will become 4. 2 raised to power 4, then it will become 8. So similarly it will go on. Sorry, it will become 1 minute. Okay, then we have stationary phase. Since stationary, the no more cell division can take place, and after that last is death phase. Okay, thank you.